All right, so as a little review of what we talked about yesterday, we started talking about that we're going to be doing the quadratic formula. The formula isn't going to change. What's going to be the difference is in these set of problems, they're going to be irrational, or in other words, those square roots are not going to be perfect squares. So we practiced a couple things yesterday. We practiced just taking a simplified radical and turning it into a decimal and learning how the different calculators work. Sometimes you had to do double parentheses because they put the number under the radical in a parenthesis. Sometimes you have to space over before you do the parentheses so that the parentheses not under the radical. There's all kinds of little changes depending on your calculator and what it does. And then there was, if you have one that has math mode and it leaves your answer as a ratio, knowing to use that standard to decimal, that S to D key, to get from that ratio to the decimal. So we spent a lot of time practicing that yesterday because I wanted to make sure that everybody knew how to use their specific calculator. And then we talked about simplifying radical expressions, where not only did we have to simplify the radical, but then we had to incorporate it with the other numbers there. Sometimes we could reduce like we did in number 6 because 4 went into 8 and 4. But other times we couldn't reduce like 5 and 7 because even though 2 on number 5, 2 goes into 6, 2 doesn't go into 7. Same thing on number 7, 2 goes into the -4, but it doesn't go into the -3. And we can't combine the 6 plus 7, I can't say that's 13 radical 2, because with radicals I can only combine like terms, I can only combine a radical 2 with a radical 2. So that's why the expression is left as it is. And then on your homework, it's going to ask you, I believe, to leave your answers in both fraction and decimal form. So now, again, the quadratic formula, nothing has changed. I'm just going to write it again. We're going to talk about it. Remembering that one side of the equation does have to be equal to 0. So we had x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Same formula we used the other day. That part has not changed. The only change is that the answers won't be as pretty, I guess you could say, as we've done. And again, one side of equation must be equal to 0. So we can't pull our A, our B, and our C until we have that set. That is a part of it, so we have to remember that as we're going forward. And again, leave your answers in simplified radical form and as a decimal rounded to the nearest hundredth. So I look at this first problem here. M squared plus 12m minus 24 equals 0. The right-hand side is already equal to 0, so I can go with my A, my B, and my C. And again, if there's nothing in front of the m squared, that's like A is equal to 1. So when I go to substitute in, I have x equals negative 12, because B is 12, plus or minus the square root of 12 squared minus 4 times 1 times negative 24, all divided by 2 times 1. So now I need to simplify that. X equals negative 12 plus or minus the square root. I know that 12 squared is 144. Negative 4 times 1 is negative 4. Negative 4 times 24 is positive 96. All divided by 2. So I take the 144 plus the 96, and I get 240. So x equals negative 12 plus or minus the square root of 240 divided by 2. Now at that point you could go right into your decimal mode because you don't have to have the simplified radical. Now some of you, if you do have a calculator that does math mode, it will simplify that radical 240 for you. But I know not everybody has that math mode available, so some of us may have to simplify that radical 240 by hand, and that may take a little bit more work. Again, if you have a calculator in math mode, if you type in negative 12 plus the square root of 240 divided by 2 and you hit enter, it's going to give you back a ratio, and it's going to tell you that the only problem is it will also, if there's anything else that can be simplified there. So if you need to simplify 240, I have the 1 times 240, 2 times 120, 3 goes in there, 3 times 80, 4 times 60, 5 times 48, 6 times 40. And if you wanted to use any of those, like if you wanted to use, we talked about this a little bit yesterday about simplifying. So if I wanted to start, like I know 4 goes into it. So if I wanted to start there, and I wanted to say that the square root of 240 is the square root of 4 times the square root of 60. Instead of having to go through and find the exact one, I can take that square root of 4 as 2, but then I can do the same thing for 60. 60 divided by 4 is 15, so I could also say, well, this is the square root of 4 times the square root of 15. So the 2 comes down, we already took that square root, the 4 comes down to a 2, so 2 times 2 times the square root of 15, which brings all this down to 4 radical 15. So you can, if you want to find, for these bigger numbers, find a perfect square, find one you know right away, and then you can keep working on the other number and we can keep simplifying. So this would be x equals negative 12 plus or minus 4 times the square root of 15, all divided by 2. But again, I can divide here. I have a negative 12, I have a 4, and I have a 2. So in this case, 12 divided by 2 is 6, 4 divided by 2 is 2, 2 divided by 2 is 1. So in simplified radical form, my solution set would look like this. -6 plus 2 radical 15, -6 minus 2 radical 15. I can't go any further with that because I can't subtract or add the -6 and the 2's. And now you could put that into your calculator, that simplified, put that in and find your decimal value. If I enter -6 plus 2 radical 15 into my calculator, again, my calculator is in math mode. So I hit that fraction to decimal or standard to decimal. And in decimal form, rounded to the nearest hundredth, that you should get 1.75 for that value. And then if I do -6 minus 2 radical 15, I get -13.75. So those would be my two answers, one in simplified radical form, one in decimal form. And again, the quadratic formula hasn't changed. It's just a matter of how we are simplifying, because we don't have that perfect square anymore. And if you're having trouble with the decimal part still, hopefully we'll have a few minutes at the end where we can look at that again as to how to get those answers. Number 10, 7n squared minus 3n minus 19 equals -7. This time I don't have one side equal to 0, so I need to do that first. I have to add that 7 to both sides so that I have everything on one side of my equation. So I have 7n squared minus 3n minus 12 equals 0. And that's what I'm going to use for my A, my B, and my C values. Because again, one side of my equation must be equal to 0. So x equals -3 plus or minus the square root of -3 squared minus 4 times 7 times -12, all divided by 2 times 7. So again, at this point, I have simply taken the values of A, B, and C once we set one side equal to 0. So I have that double negative out front there that I want to take care of. So x equals 3 plus or minus the square root. -3 squared is +9. -4 times 7 is -28. -28 times -12 is +336. And that's all going to be divided by 14. So x equals 3 plus or minus the square root of 345 divided by 14. For those of you that have a calculator with math mode, what happens when you put in the square root of 345? What do you get back? The square root of 345. What is that telling me if I put in the square root of 345 and I'm getting back the square root of 345? No, if you have a calculator that has math mode and it's not changing it, it's telling you that that can't be simplified. Now, we could do some work on that. Being that it ends in 5, I know that 345 obviously is divisible by 5. So if I look at the square root of 345, it's the square root of 5 times the square root of 69. Well, 69 only has a couple ways. It has 1 times 69, and then I think it's divisible, and 3 times 23. So the square root of 69 is the square root of 3 times the square root of 23. Are there any perfect squares in any of that? No. So you actually can't simplify the square root of 345 any further. Radical 5, radical 3, and radical 23 are all prime and can't be simplified. So my solution set here, I have 3 plus radical 345 divided by 14 and 3 minus radical 345 divided by 14. Now, sometimes in solution sets, you will see them write the plus and minus together like we have up here in this line with the x equals. So sometimes they will write their solution set as 3 plus or minus the square root of 345 divided by 14, but you're supposed to separate them out. So now I have to use my parentheses because I am going to be dividing. So I have to set this up 3 plus the square root of 345. And again, make sure you remember about how do you get that parentheses. For me, I had to use my navigation arrow and go one to the right to end my parentheses before I do the divided by 14. And I get 1.54 as my decimal. Then I do 3 minus the square root of 345 divided by 14. And I get negative 1.11. So those, I have my answer in simplified radical form and in decimal form rounded to the nearest hundredth. All right, number 11. N squared minus 8n equals 21. Again, first thing I have to do is move that 21 over so that I have n squared minus 8n minus 21 equals 0. So that now I have my A, my B, and my C. And again, because there's nothing in front of that n squared, A is going to be 1, B is going to be negative 8, C is going to be negative 21. And now I substitute into my equation. X equals negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times negative 21, all divided by 2 times 1. So I have the double negative here. That's going to go positive, so x equals 8 plus or minus the square root. Negative 8 squared is positive 64. Negative 4 times 1 is negative 4. Negative 4 times negative 21 is positive 84. All divided by 2. So x equals 8 plus or minus the square root of 148 divided by 2. So I need to see if I can simplify the square root of 148. I have 2 times 74. Let's see if it's divisible by 4. 4 times 37. So the square root of 4 times the square root of 37. Square root of 4 is 2. Square root of 37 can't be simplified, so we will replace that square root of 148 with 2 radical 37. So x equals 8 plus or minus 2 times the square root of 37 divided by 2. And again, this time we do have a simplifying situation because I have 8, 2, and 2. 2 divides into all of that. So I can simplify that. 8 becomes a 4. This 2 becomes a 1, and this 2 becomes a 1. So x equals 4 plus or minus radical 37. When that is simplified. So 4 plus radical 37, 4 minus radical 37 would be in simplified radical form. And then we just got to get that to decimal form. So 4 plus radical 37, we should get 10.08. Rounded to the nearest hundredth. And 4 minus radical 37, negative 2.08. So again, simplified radical form and decimal form rounded to the nearest hundredth. Number 12, negative 3x squared minus 12x minus 17 equals negative 9x squared plus 2x minus 4x, plus 2 minus 4x. So we have we have to add 9x squared to both sides. We have to add 4x to both sides and subtract 2 from both sides. That cancels out everything on the right-hand side of that equation. So negative 3x squared plus 9x squared gets me 6x squared. Negative 12x plus 4x is negative 8x. Negative 17 minus 2 is minus 19 equals 0. And again, now that I have one side of my equation equal to 0, now I can label my A, my B, and my C. And then I can start substituting into my equation here. B has a value of negative 8, so negative 8 plus or minus the square root of negative 8 squared minus 4 times 6 times negative 19, all divided by 2 times 6. So I have that double negative situation out front, so I know that 8 is going to end up being positive. So x equals 8 plus or minus the square root. Negative 8 squared is 64. Negative 4 times 6 is negative 24. Negative 24 times negative 19 is positive 456. All divided by 12. So I end up with x equals 8 plus or minus the square root of 520, all divided by 12. So to simplify my my radical, I don't know, if I always feel like I kind of go to my go safe of 4. So I know that's the square root of 4 times the square root of 130. 130 is not divisible by 4. 130 is not divisible by 9. 130 is not divisible by 16. I know it's not divisible by 25. It's not divisible by 36. So when I'm checking for all my other perfect squares here, I'm not finding anything else that goes into 130. So this would simplify down. And if you think about 130 is 13 times 10. 10 is 2 times 5. There's no perfect squares in 13, 2, or 5. So we know that that's 2 times the square root of 130. So x equals 8 plus or minus 2 radical 130 divided by 12. Again, this time I have 8, 2, and 12. They're all divisible by 2, so my 8 goes down to 4, my 2 goes down to 1, my 12 goes down to 6. Now, we're still going to have a denominator this time. It doesn't mean because you reduce that you always lose the denominator. This is going to be x equals 4 plus or minus the square root of 130 divided by 6. So 4 plus radical 130 divided by 6, 4 minus radical 130 divided by 6. And then I have to turn those into decimals. Because I have a denominator, I need to make sure and use my parentheses so that it takes 4 plus the square root before it divides by 6. And for the first one, you should come out to a decimal of 2.57. And the second one, a negative 1.23. So again, those solutions are still telling me where that function is crossing my x-axis, whether it's in simplified radical form or in rounded decimal form. It's still telling me the same thing.